Hello, good morning, everyone. Today we're going to talk about Pythagorean Theorem. All right, and we need to remember that Pythagorean Theorem is when we have a right triangle. And we also need to remember that the formula for Pythagorean Theorem is on our formula charts. So, knowing that a Pythagorean Theorem is used for a right triangle, we need to remember that the side across from the right angle is called my hypotenuse. Okay. And in our formula, it is always the letter C. Okay, so the side across from the right angle is always our letter C. Now, for the other two sides, those are called our legs. Okay, and those I can use as A or B, and I can interchange them. I can switch them. So this could be B, this could be A. That doesn't matter. The most important one with Pythagorean theorem is our C, and our C being that hypotenuse, all right? Okay, so we have our formula here, A squared plus B squared equals C squared. And I'm going to show you that I can prove this to be true. So again, our C is across from our right angle. So that's going to be my C. And then my A and my B can be either leg over here. Now our C, our hypotenuse, is always going to be the longest side. So I'm going to count how long my side, I'll say this is A and this one's B. So A is 1, 2, 3 units long. So I'll say 3 squared. B is 1, 2, 3, 4 units long. So plus 4 squared equals C, and we said 1, 2, 3, 4, 5 units long. Okay, so I am going to square them. Okay, and I made a square out of them. So when I do 3 squared, if I typed that in, I get 3 squared, and my answer is 9. Well, I do notice that there's 1, 2, 3, 4, 5, 6, 7, 8, 9 squares for that side, all right? And if I did 4 squared, I would do 4 times 4, and that gives me 16. So again, if I counted, I would get 16 squares. And then it says it equals 5 squared, or 5 times 5, which would give me 25. So if you think back to when we learned this lesson, we moved all our squares, our little units, from this square A, fit it into square C, fit all our squares in B over here in C. And so let's see if that would work. If I had 9 squares here in A, and I added them to the 16 squares here in B, it does in fact equal 25. And so that is what Pythagorean theorem is telling us, is that when I square the side lengths, the legs, on a right triangle, it's going to equal the square of the hypotenuse. Okay, so let's go ahead and start with our first example. So example 1 says, has a side length of 5, a side length of 12, and a side length of C. So I'm going to always start by drawing that arrow from the right angle. And then again on my formula chart, I do have the formula in case we don't have it memorized. A squared plus B squared equals C squared. Now I'm going to pick which ones are my A and my B. C is already labeled. I don't know what that is. So 5 can either be A or B, and 12 can either be A or B. We'll get the same answer. But I'm going to go ahead and just say 5 is A and 12 is B. So 5 will go where my A is, squared, plus B, that's going to be my 12, and I'm going to square that, equals C, and we don't know what C is, so I'm just going to leave it as C. So then I'm going to actually square it. So 5 squared is 25. Whoa. Plus 12 squared, 144. And it's going to equal C squared. So as I keep working through this problem, I have 25 plus 144. I can type that in the calculator and get a number. So I'm going to 25 plus 144, and it equals 169. And that's going to equal C squared. Now, I just want regular C. So in order to do that, I need to do the opposite of squaring something, which is to square root it. So I'm going to square root 169, and that will give me my C. Square root 169, I get C equals 13. Okay. So I am going to go ahead and start on example 2. We're going to work it in the same process. The only difference is there are a couple decimals here, but that's okay. So when I draw that arrow over, I am looking for my C. I can go ahead and label my A and my B. So A squared plus B squared equals C squared. A was 7.8 squared plus B, which is 8.2 squared, equals C. I don't know what C is, so I'm just going to leave it. Now I'm going to actually square them. So 7.8 squared gives me 60.84 plus 8.2 squared, which gives me 67.24. And that equals C squared. So again, as I'm starting to read this, I can add 60.84 plus 67.24. So 60.84 plus 67.24, and that will give me 128.08, and that equals C squared. So I definitely need to remember that I'm only looking for C, so I need to do that last step, which is to take the square root. So when I take my square root of 128.08, I get 11.317. Now we are going to round to the hundredths place. So that's 2 after the decimal. So that 7 is greater than 5, so I'm going to round up. So 11.32 is my side length for C on example number 2. So now that we've worked 2 with the picture, we are going to go ahead and work 1 with a word problem. Jane and Zachary start walking at the same point. So here's the point. But Zachary walks 5 feet north. So this is where they start. Zachary goes north 5 feet, while Jane walks 75 feet east. Okay. So Jane walks east this way, so 75 feet. I'm going to move Zachary's 5 outside. How far apart are Jane and Zachary when they stop? So if I drew my line in there. I see a right triangle now. So again, we're going to start the same. It wants to know how far apart they are. So there's Jane, here's Zachary. We are looking for our C. So I'll say 5 will be A, 75 will be B, A squared plus B squared equals C squared. So I have 5 squared plus 75 squared equals C squared. So 5 squared is 25. 75 squared is 5,625. And that's going to be C squared. So again, I can add up 25 plus 5,625. 25 plus 5,625 gives me 5,650 equals C squared. But we need to remember to take that square root. So they are, let's take the square root, 5,650. I have 75.166. So if I round, that 6 tells me to add one more. So they are 75.17 feet apart from each other. All right, so moving on to example number 4. On this one, when we draw our arrow from our right angle, we can see that this one points to our C. All right, and on here it says that we're looking for A. All right, so if I'm looking for A, I know that 7 is going to be C, then that means 3 is going to be my B. So I'll have A squared plus B squared equals C squared. A squared, I don't know what A is, so I'm going to leave A there. Plus B squared, so that'll be 3 squared, equals C squared, which is going to be 7 squared. Can't do A squared, so I'm going to leave A squared. But I can do 3 squared, and I know that 3 squared, or 3 times 3, is 9. And then 7 squared, or 7 times 7, is 49. Now, on examples 1, 2, and 3, we could add up this number plus the other number. But on this one, I can't add it because I have an A there, and I can't add a number and a letter. So instead of adding, I am going to have to subtract. So I'm going to subtract 9 on both sides. So then I'm left with A squared equals 49 minus 9 is going to give me 40. And then my last step, I still need just regular A, not A squared. So I still need to take the square root. So when I take the square root of 40, I get 6.324. And that 4 tells me to stay the same. So I'm just going to erase it because I'm running out of room. So side A is 6.32 units long. Okay, so now we're going to do example 5. So again, I'm going to draw that arrow from my right angle, and I need to remember that's going to point to my C. It tells me that I'm looking for B, so that means 7 will be my A. So A squared plus B squared equals C squared. A squared is 7. B squared, I don't know what it is, so I'm going to leave B there, B squared. And C squared is going to be 25 squared. So now I'm going to square 7. So 7 squared is 49. Plus, I can't do B squared, so I'm just going to bring that down. And then I am going to do 25 squared. And that gives me 625. Okay, so again on this problem, I can't add up a number plus a letter. So I have to do the opposite of addition. I'm going to go ahead and I'm going to subtract. Now that's gone, and I have b squared equals, so I'm going to do 625 minus 49, and I get 576. And then I only need b and not b squared, so I will take the square root. So the square root of 576 is 24. So b is 24 units long, all right? So now let's go ahead and do our last example. Now I do want to go ahead and draw a picture with this one. It says, Bobby leans a 15-foot ladder against his house. The base of the ladder is placed 4 feet from the base of the house. How far up the house does the ladder reach? So here's my picture. Here's Bobby's house. Here's Bobby's ladder. Okay. Now it says Bobby leans a 15-foot ladder. So the ladder is 15 feet long. The base of the ladder, so the bottom part of this ladder, is 4 feet from the base of the house. How far up the house does the ladder reach? So in my picture, I can see my right triangle. So my arrow points to my C, and I can decide on my legs. So I'll say that A will be X and B will be 4. So A squared plus B squared equals C squared. A squared got X squared plus B squared is going to be 4 squared. And C squared, C is 15 squared. I cannot do X squared, so I'm just going to move that down. 4 squared, or 4 times 4, is 16. And then I have 15 squared, and that's 225. Okay. Now again, right here, I have a letter plus a number. I can't do that, so I need to do the opposite of addition, which is to subtract. So I'm left with x squared equals, so I have 225 minus 16, and that gives me 209. And again, I need 1x, not x squared, so I'm going to do the inverse or the opposite operation. So x is going to equal, and I need the square root of 209. All right, that will give me 14. Let me fix that, sorry. That'll give me 14.456. In 8th grade math, we round to the hundreds place. So that 6 tells me to round up. So the ladder reaches 14.46, and these say feet, up the house. Okay, please make sure your foldable is completely filled out like mine, and have a good day.